Good day, everyone. Now, in grade 8, you were introduced to quadrilaterals, right? So in this lesson, we will revise the properties again, build on it, and continue with more advanced problems. Right. So a quadrilateral is a polygon, which is actually a closed shape, with 4 sides, 4 vertices, and 4 angles. Right. So this quadrilateral over here, we call that a quadrilateral A, B, C, D. You can also call it B, C, D, A, C, J, D, A, B, or D, A, B, C. Normally, we do it in alphabetical order, right? So, it has 4 sides, as you can see, A, B, B, C, C, D, and D, A. It has 4 vertices and 4 angles. Angle A, B, C, and D. Now, it has 4 pairs of consecutive sides. What's a consecutive side? A, B, and B, C, because it has a common vertex. We can also call that adjacent sides. Right, so we have A, B, and B, C, they are one pair. Then we have another pair, B, C, and C, D. Remember, C is the common vertex. Then we have C, D, and D, A. And lastly, we have D, A, and A, B. They are adjacent sides. Right. Now, it has 2 diagonals. Now, what is a diagonal? It's a line segment connecting the opposite vertices. Right. So, there we have 1. And we call that diagonal AC. Then we have another one, DB. So it is a line segment connecting the opposite vertices. Right. So what is opposite angles? Now the opposite angles are those connected again by the diagonals. So angle A is opposite angle C, and B is opposite angle D. Right. Now the sum of the 4 angles of a quadrilateral is equal to 360 degrees. You can test this and you can add them all together and you will get 360 degrees. So remember this property, the sum of the 4 angles of a quadrilateral is equal to 360 degrees. Now all types of quadrilaterals have some properties that are similar, but each one also differ in some aspects. Now we are going to classify them based on their sides and angles. Now I group this 4 together because they have very similar properties, but also some different. So it's the parallelogram, the rhombus, rectangle, and the square. Now all 4 of them, they are quadrilaterals with 2 pairs of opposite parallel lines. Now the parallel lines, they are marked with arrows, right? So you can see here we have a pair of parallel lines or parallel sides, and there we have 2 parallel sides, right? And we start with parallelogram. So as I mentioned now, both pairs of opposite sides are parallel, right? Now, both pairs of opposite sides are equal. Now, equal I mark with a line or 2 lines. So, this red ones, they are equal. The yellow sides, they are equal. So, both pairs of opposite sides are equal. And both angles, opposite angles, they are equal in a parallelogram. You can see why and why. Opposite angles, they are equal. Now we get to the next one, the rectangle. Very similar to the parallelogram, both pairs of opposite sides are parallel. Right. You see there and over there. Then both pairs of opposite sides are equal. 1 and over there. But now we come to a different aspect. All angles equal to 90 degrees. So all the angles are equal to 90 degrees. In a parallelogram, both pairs of opposite angles are equal. That's the difference. Right. Then we get to the rhombus. Same, both pairs of opposite sides are parallel, and also both pairs of opposite angles are equal. And lastly, a very important one, all four sides are equal. Right? All four sides are equal of the rhombus. The rhombus, all four sides are equal. But the opposite angles are equal, and both pairs of parallel lines or parallel sides, both pairs of sides are parallel. Then lastly, the square. Same story, both pairs of opposite sides are parallel. Also the same like the rhombus, all four sides are equal. Right, but the same like the rectangle, all angles, they are all equal to 90 degrees. Each one is equal to 90 degrees. Right, now we get to the last two. The quadrilateral with one pair of parallel lines, that's a trapezium. Only one pair of parallel lines. The non-parallel lines are not equal, and the parallel lines are not equal. The parallel sides, they are not equal. So the four angles are not equal. Right. So sometimes you can also call that the scalene trapezium, because no angles are equal. Then the next one, also trapezium, one pair of parallel sides. Right, two non-parallel sides, but in this example, this one, the two non-parallel sides are the same length. And what do we call this one? An isosceles trapezium. Right, isosceles trapezium. Okay, so in an isosceles trapezium, the two non-parallel sides, these two, they are equal in length. Also, only one pair of parallel lines. Then lastly, the quadrilateral with no parallel lines, nothing at all. Right, we call this the kite. But you see these two sides here, they are adjacent and they are equal. Then we have another pair of adjacent sides. Remember, what's adjacent side? It share a common vertex. Right? So in here we have two pairs of adjacent sides. Now this line over here, this blue line, we call that the symmetry line, or we can even call that a diagonal. Right, because from this point, the line with the line start by this vertex right through to the other vertex there. Symmetry line. Now the symmetry line divides the kite in two identical shapes. Right, two identical shapes. Now this line also bisect this angle here, Z and Z, bisect that angle there. Right, and the two angles opposite the line of symmetry, they are equal. Let's go over that again. So we have two pairs of consecutive or adjacent sides, and they are equal. So it's this side and that side. Angles are equal opposite the line of symmetry. So this angle is equal to that angle over there. And the diagonal bisect the angles into which it runs. So it runs from there to there, and it bisects this angles. So that is our quadrilateral, classified according to their sides and their angles. Now we are going to classify them according to their diagonals. Right? So a diagonal over here and over there. That's our two diagonals in our rectangle. I mark them the same because this diagonal over here bisect that one, and that diagonal bisect the second one there, with the result all four halves, they are marked the same. So we say in a rectangle the two diagonals are equal. Right, so the rectangle has two diagonals. Diagonals bisect each other. You know, bisect mean half, divide them into halves. Right, and the diagonals are equal. That's why I have the same color here. They are equal. Next, now the parallelogram. Also two diagonals. Right, diagonals also bisect, but the diagonals are not equal. Right, that's why I marked them in different colors here. So this half is equal to that half because the black diagonal bisect the reddish one. Right, so this diagonal and that diagonal, they are not the same. They are not equal. Their length is not the same. Right, so the square, two diagonals again, and this diagonal bisect this one here, the same over here, and the diagonals bisect each other at right angles. So the moment these two bisect, you get angles of 90 degrees. Right, and the spike diagonal and that diagonal, they are equal, same length. Then lastly we have the rhombus. Two diagonals, right, bisect at 90 degrees, and the diagonals are not equal. I know it's a lot to remember. That for that reason I actually have a summary here, and we go through that summary quickly. Each has two diagonals. This group, all of them, this four. Remember, we have 6 of them. So this 4, each has two diagonals. Each one's diagonals bisect each other. All of them bisect. Right, bisect. Divide into halves. Now the diagonals of the rectangle and the square, this is important, they are equal. Alright, in the rectangle and in the square, the diagonals are equal. That the diagonals of this parallelogram here and the rhombus, they are not equal. The diagonals of the square and the rhombus bisect at right angles or at 90-degree angles. Whoops, right. Now we get to the last two. Trapezium. Also two diagonals, but the diagonals are not equal. Right. Then we get lastly to the kite. Two diagonals over there. You see there? Okay. Now, the diagonals bisect at 90-degree angles. Right. The longer diagonal divides the shorter diagonal into two equal segments. You see there? Two equal segments. and the shorter diagonal, this one, does not bisect the equal opposite angles. So if you look at this angle, this one, or let me take this yellow, from there to there and there, they are opposite angles and they are equal, right? So this line or this diagonal does not bisect them into two equal angles. So if Z is 40, Y will be 50 or whatever. They are, this line does not bisect the opposite angles. That you must also remember. So now we are going to start with this worksheet 1. Okay, you must now classify the following quadrilaterals and give a reason to justify your answer. So we will look at the different properties before we start. Okay, so we look at this property. Two adjacent sides are equal. Two opposite angles are equal. So that can only be the kite. Right. Reason, adjacent sides are equal, opposite angles are equal. Look at the next one. The two diagonals bisect at 90 degrees. So it can be a square also, and it can be a rhombus. So why is it not a square? It is not a square because in a square the diagonals are equal. This is a rhombus because the diagonals are not equal. Okay, so a rhombus, diagonals bisect at right angles and the diagonals are not equal. Then we have C. C is a C. Now we first look at the diagonals here. The diagonals are equal. So this can be a rectangle or a square. Now why is it not a square? Because of this angle over here, 80 degrees. In a square, the two diagonals bisect at 90 degrees. So this is a rectangle. Diagonals are equal and the diagonals do not bisect at 90 degrees. Then we get to D. Only one pair of parallel lines. So it can only be a trapezium. Right. One pair of opposite sides are parallel. Then we have this figure over here. You see there? The two diagonals bisect at 90 degrees. So it can only be a rhombus or it can be a square. So it's a square. Why is it a square? Because the diagonals are equal. You see there the difference? Diagonals not equal, diagonals are equal. So this is a square. And it bisects at 90 degrees. Last one. You see the opposite angles are equal. The opposite angles are equal. So this can be a rhombus or it can be a parallelogram. Why is it not a rhombus? Because in a rhombus all four sides are equal. So this can only be a parallelogram because in a parallelogram the opposite angles, they are equal when the two sides are parallel or the two opposite sides are equal, and that too they are equal. Right. So what do we have here? A parallelogram. Opposite sides are equal and the opposite angles are equal. We continue with worksheet 2. We are going to solve problems now with quadrilaterals. So first of all, you must classify this quadrilateral, and then you must find x and y, and you must give reasons for your statements. I say here A, B, C, D is a parallelogram, but why? You see the two opposite sides, they are equal. This side and this side, that side and that side over there. Right? And yeah, for now that's all. I didn't actually ask a reason, but A, B, C, D is a parallelogram. Opposite sides are parallel and opposite sides are equal. Now find x and y. X is over here, y over there. Okay. I can see two triangles, and I can see angles in between parallel lines. You see there? This line is parallel to this one. So we can even call this now a transversal, although it is a diagonal, right? We can also call this now our transversal. So x is from this parallel line to that transversal, and from the same transversal to that parallel line is 45 degrees. So x and 45 degrees, they are alternate interior angles, and they are equal because AD is parallel to BC. So you must say there that AD is parallel to BC, and it is given to us. Given means it is marked already, right? It's marked. Now in the next step you say x is equal to 45 degrees, or therefore x is 45 degrees because they are alternate angles. Now as soon as you have that answer, you write it in 45 degrees. Why? Now before we continue, remember the rule. In a parallelogram, the opposite angles, they are equal. So A is equal to 110 degrees. I just want to mention that also. You write it in, but do you need it here? Yes, you can use that method. That we have a triangle over here. So 110, 45 and y, they are equal to 180. Or you can use this one. These two lines are parallel, so from there to there and from there to there, they are co-interior angles. Remember, co-interior angles in between two parallel lines on the same side of a transversal. Now I'm going to use this method, right? But before I continue, I must first say that AB is parallel to CD. It is given to us. There, you can say it's given. And for that reason, y plus 45 plus 110 is equal to 180 co-interior angles. So y is equal to, and we subtract, and y is equal to 25. Right, that is the one way to get it. Then we do the other way too, but you can do any one, or you can do this way. You must first say why A is equal to 110. Now A is equal to 110 because the opposite angles of a parallelogram, they are equal. So A 110, opposite angles of parallelogram are equal. Now in our next step, y plus 110 plus 45 is equal to 180 because the sum of three angles of a triangle. And there we have it. Y is equal to 180 minus 110 minus 45. Three angles of triangle equal to 180. Y is equal to 25 degrees. You have that? So you can or use this way, or you can find it through that method. Next one. PQRS is a rectangle. Find A and B. Right. So where do we start? We start by filling in everything we know about a rectangle, right? So I know in a rectangle the diagonals are equal, so I'll mark it there, 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 and over there. Now you must find A and B. I have 104 here, so I'm going to use triangle. Alright, let me just mark it or highlight it. I'm going to use this triangle here because I can see it's possible to get to this answer right over there. Okay, where do we start now? Where is my pen? Okay, there we are. You can see here, these two sides, they are the same. So we actually have an isosceles triangle here. And it is possible to find 2, because 2 and 104, they are vertically opposite angles. Right, so 2 is equal to 104 vertically opposite angles. So I'll write it in here. Right, okay. 104. To find A and S1, now you know they must be equal because angles opposite equal sides, they are equal. Right, the angles opposite the equal sides, they are equal. So in the next one we will say that this QO is equal to OS. Why? It's because the diagonals of a rectangle, they bisect and they are equal. Right, bisect and they are equal. So in the next one you will say that A and S1, they are equal because they are opposite the equal sides. So A is equal to S1. Why? Because angles opposite equal sides. They are opposite the equal sides. So now in the next step you will find the sum of A and S1. Right. So to get that, we say A plus S1 is equal to 180 minus this 104 degrees. Reason, three angles of triangle or sum of three angles of triangle, and A plus S1 is equal to 76 degrees. So A is half of 76. A is equal to 38 degrees. We write it in. Okay, 80, 38, 38 degrees. Now we must move to B. Now it's given to us that angle Q, you see there, is 90 degrees. We have the little box there. So it's quite easy to get to B. Subtract the 38 from 90 degrees and we'll get B. But this is the way we write it out. Q is equal to 90 degrees given. The box is given to us. It's telling us that this angle Q is 90 degrees. Subtract and we get 52 degrees. So this angle is 52 degrees. Right. Number C. Here they say you must classify the following quadrilateral and you give a reason for your answer. So let's see, what do we have? All four sides are equal. This can only be a rhombus or a square. But it's not a square because the angles are not marked with a box to tell us that it is 90 degrees. So it must be a rhombus. Right. So ABCD is a rhombus because all four sides are equal. Now before I start with my start working out the problems, I'll first write in or mark what I know about a rhombus. Right, so I know that the rhombus, the diagonals, bisect at 90 degrees. So I'll do that. Bisect at 90 degrees so that I can remember that when I do my problems or my sums. Now what do I want first? I want x. I want x over there. So how can I get to x? Right? Now x and 2, they are alternate angles, but no. Right, I can't because I don't know the value of x, I don't know the value of y. So I have already one angle here. So I need another angle, the value of another angle to find x. Let's see 64. And here we can see 64 and angle 2, they alternate angles. You see here? AD parallel to BC. So angle 2 and 64. And 64 there. Right. They are alternate interior angles. So I will first say that AD is parallel to BC. Right. And for that reason, angle A2 is equal to 64 degrees. Alternate interior angles. So we have that 64. Now we have two angles of a triangle, so it's easy to find the third one because we subtract this 2 from. We subtract it from 180. Right. Sorry, excuse me. Right. So in this step, 04 here is equal to 90 degrees. Why? Diagonals bisect at 90 degree angles. Right. Next step. X plus x is equal to 180 minus that 64 minus this 90, or minus the 90 minus the 64. Why? 3 angles of a triangle, and we get x is 26. Now we want y. Okay. I can actually see that y and 34, they are alternate interior angles. Can you see there? From the parallel line to the transversal, from that parallel line to the same transversal. So it's like this. Right. So AB is parallel to CD, and that means that y is equal to 34 degrees. So AB parallel to CD, therefore y is equal to 34. Reason? Alternate interior angles. Right. Then we move to the last one. Classify the quadrilateral. Give reasons for your answer. I can see this 2 diagonals, right? They bisect at 90 degrees. No lines are parallel. So I know immediately that this can only be a kite. So D, E, F, G is a kite. Opposite lines are not parallel. You see these opposite lines? They are not parallel, or they're not even equal. They're not even marked equal. But very important, the diagonals bisect at 90 degrees. So I mark what I know. I know that the opposite angles, the two angles opposite this diagonal, the long diagonal, they are equal. There. Alright, so if this is 110, this D must be 110. Okay, so what I'm going to do now is I'm going to use this triangle here. Because if I know this one is 110, then I only have one unknown, and that is x. Right, so x plus that x minus 10 plus 110. You see this triangle here? Right? The big one. That one. I'm going to work with that triangle now. So 110x and x minus 10 degrees, they equal to 180. But I must first say why this D is equal to 110. Now D is equal to 110 because the opposite angles of a kite, they are equal. So D equal to 110 degrees, angles opposite the long diagonal here. The long diagonal, they are equal. Right, so my equation, 110 plus x minus 10 degrees equal to 180 degrees. Why? Three angles of triangle. Add the x, 2x is equal to 180 minus 110, right, minus 110 plus 10 degrees, 2x equal to 80. So 1x is half of 80 and it is 40. Right, so x is equal to 40 degrees. Right. Now you must find y. Y is over there. Now this angle here is 90 degrees. So obviously that one is 90 degrees because we know diagonals bisect at 90 degree angles. So it will be easy to find y because now we have the smaller triangle here. So y plus 90 plus 40 is equal to 180. Okay, but we must first say this angle is 90 degrees because diagonals bisect at 90 degree angles. So DOE is 90 degrees. Diagonals bisect at 90 degrees. Next step, y is equal to 180 minus this 90 minus that 40 there. Three angles of triangle and y is equal to 50. Right, 50 degrees. Now the last one is z. What do we know? We know that the angle from there to there is 110, which means that y plus z is actually 110. So if y is 50, then z must be 110 minus that 50. Right. So we say D is equal to 110, opposite angle F. Alright. And Z is equal to 110 minus 50, and Z is equal to 60 degrees. Okay. Now if you did not grasp the properties of the quadrilaterals in this lesson, then I want you to watch it again until you fully understand it. And then you do the two worksheets again on your own. Thanks a lot. That's all for today.